Hello, hello, welcome back to the lab, welcome back to EE for everyone. Got a very exciting video for you today. I think this whole project would fit in one shot of our microscope. There it is. Every now and again, you meet someone, that special person who lets you tinker in the lab and doesn't question why you'd rather stay in on a Friday night and record a video about a circuit board you made instead of going out to the bars. And yeah, COVID, whatever. But this COVID did not change my behavior about my preference versus going to the bars. And so like I said, every now and again you meet that special person that just, and every now and again, you know, despite how that person might feel about you, when you buy a new power supply and an LCR meter and a microscope and an oscilloscope and a turntable and a camera, every now and again, you just gotta turn around and pay the piper. Why do I let you have all that crap? Well, here's why. So, here's the problem. Here's what was going on. Basically, I'm sure a lot of you have seen stuff like this. It's a string of LEDs. It's really nothing special. It's a string of a bunch of LEDs that, as far as I can tell, are wired in parallel with a single current limiting resistor up at the front. They might have a little resistor in each one, but what I saw was a battery pack that had a little resistor in it and a switch. And I thought, man, we are going to burn 1,000 AA batteries. And so I took matters into my own hands. I took a little board that accepts USB and converts it down to 3.3 with two little series current limiting resistors that drop the minuscule voltage required to go from 3.3 volts to the right around 3 going into these LEDs, just limiting the current to a similar level. And this might seem kind of simple on the surface. Took basically a 3-volt battery pack, converted it to a 3.3 volt LDO. Maximum current is 500 milliamps through a fuse on the front to make sure I'm not going to damage anything. But there are some little nuances about this project that I think make it especially interesting. You know, by using this standard connector, and electronics are crazy these days, right? And TVs, especially, have gotten a lot smarter, meaning that a lot of TVs already have a USB port baked in. My oscilloscope has a USB port baked in. So the beautiful thing about keeping this current below 500 milliamps, and actually even one of my power supplies has a USB port built in. That's nuts. Why? Why would anybody need that? But hey, while we're talking about it, let's use that. Oh, what was that? Okay, it wasn't expensive. It's kind of nice that instead of burning a bunch of AA batteries, I can power these LEDs with my lab power supply. Plug it right into the front. I can power them with a TV. With just a few moments of effort, I never need to change the batteries ever again. It just makes me sad to think about how many batteries people are throwing away when, you know, a different solution is not that much more expensive. And I know it's not a perfect solution. There's many people in the world that wouldn't be willing to accept this kind of circuit board, but, you know, you make it with a black PCB and you add a nice small connector or a small board. It's basically the same width as a USB micro B, and there you go. So, just, yeah, for what it's worth, we're going to put these files out there. You might find that someone in your life has a similar need, and you know what? LEDs are cool, and I like LEDs everywhere. So I guess let's round this out by terminating another one of these, because I ripped a cable out. And what I want to talk about is just kind of my vision for the channel. And for a very long time, we've been doing huge projects. And in 2021, we're trying something a little bit different, and instead of focusing on 2 or sometimes even 1 giant project, I want to try to do more simpler projects, or build up a large project over time through a lot of smaller projects. There's a part of reasons why. There's actually been some folks that maybe they're new to the channel, or maybe not, but they questioned kind of how short some of the videos have been. And yeah, that's actually not really a desire to keep a video short, but what I try to do is I try to make every video have a purpose. So for example, when we make a video about like BJTs, or the Class AB series, that's a perfect example. So when we were making that series, of course, the temptation is to explain every little detail about a Class AB amplifier. And rather than in that Class AB amplifier video, rather than trying to explain everything, so we could have tried to explain transistors, maybe even do BJTs versus MOSFETs. We could have done a lot of different explanations. And rather than trying to do all of that in one video and making a 30-minute book, something that I think is a good direction for EE for everyone, and just generally a healthier learning style, is to, rather than that, make one piece of content that focuses on a Class AB amplifier stage that's shorter, of course, because you're just talking about one thing, and then make a separate piece of content that discusses BJTs. And I think that's good for 2 reasons. Because there's a lot of people that might be interested in Class AB amplifiers that already know how transistors work, and they'd be bored if they tried to watch that whole video, and they'd be like, God, it's so frustrating, I can't just watch the part of the content I really was interested in. And of course, you'll have the people that watch that piece of content and say, I don't really understand this Class AB amplifier because I don't really understand a BJT. And that is why the dedicated piece of content needs to exist. But what I found is, a lot of our designs are using common things like buck converters, linear regulators. And I found that I kept explaining how those things work over and over and over again. And there's nothing wrong with that. There's nothing wrong with hitting the same points more than once. My problem with it was very simply, I don't want to bore you guys. I want you to be able to find the information that you're looking for in a reasonable amount of time and honestly learn what you need to learn and get on with your day. So I'm very cognizant of, if we start repeating ourselves, or if we start explaining the same thing for the 5th time, that starts to be a red flag. And where am I going with this? So that red flag got kind of raised up in my head the other day. And what I was looking at is, I was looking at some of these larger projects, and it was like, kind of like a rinse and repeat. There wasn't much room for creativity, where there was 1 or 2 videos that would be explaining the theory, and then there'd be a video for schematic capture and a video for the layout, and then there'd be a video where we do a smoke test, and a video where we start to actually flex, and then it gets kind of gray, where it just kind of, for as long as the project goes on, there's more content to discuss. And that was kind of the rhythm that these projects were in. And I was looking, and there were like 4 projects in the backlog at the same time. And I was like, these 4 series are exactly the same. There is nothing other than what we are building, like other than the physical project being built. There's nothing here to distinguish between one series and another. These are, by all counts, the exact same series, just about a different subject matter. And in some ways that's good. Consistency is good. But on the other hand, I think I want to go a different direction. So I'm hoping that as we chart the next few projects, as we plan kind of the videos, the sequence of events, I'm hoping that you'll see kind of a fresh take on what electrical engineering is. And by and large, a part of that repetition is that engineering is kind of by definition a very consistent activity. If you're designing something in a radically different way, like if your process is radically different every time you do it, that's probably not a good sign. And honestly, that's kind of how the content got to where it is. Like, there is an engineering process, and I used to harp on it a lot more than I do now. I used to be like, you got to go through an architecture phase, and you got to do this and that. And I'm not going to lie. If I had to outline the architecture of this LDO, I think you would have screamed bloody murder in the comments. That would have been the most boring piece of content I could even imagine. The architecture is it's an LDO. That's it. Hopefully I didn't flop those wires as I was rambling. But yeah, so we used to go architecture. There we go. All right. Yeah, that looks great. That's nice. So, yeah, we've terminated it to the connector, and you can plug 2 of these into the same thing. So I guess I got to be fair and demo this. So I'll turn off the studio lights. Man, look at that. Very nice. Very nice indeed. So yeah, I hope you enjoyed this video, and it was nice just kind of getting that off my chest and chatting with you guys. Yeah, special thanks to those channel members on Patreon and the YouTube channel members. Really appreciate the extra step you've taken to support us directly. But most of all, hope you learned something great today, and I hope to see you again soon. So thanks for watching EE for everyone. Thank you for staying till the end. Bye.